Here is a Buckboost converter problem, and let's do this problem together. From the question, we know that our input is floating from 12 volts to 14 volts, and the output is minus 24 volts. The nominal load resistance is 12 ohm, and the frequency is 50 kilohertz. Our current ripple is 1 amp and voltage ripple is 0.24 volts. The first question asks us to calculate the duty ratio for 12 volts and 14 volts separately. So our first question asks us to calculate the duty, and we know from last video our duty equals to the absolute value of V out divided on V out plus V in. And for 12 volts, our duty equals to 24 divided on 24 plus 12 is 66.7%, and for 14 volts our duty is 24 divided on 24 plus 14 is 63.2%. The second question asks us to design the inductor and capacitor. So also we need to design for both. V in is 12 volts. We have our inductor as V in divided on delta IL times T on, and we can replace this T on with duty and frequency, which is V in times D divided on delta IL times frequency, and we now have 12 times 0.667 divided on 1 amp times 50 kilohertz. We got 116 microhenry, and the capacitance is D times V out divided on delta V out times R times frequency, and we have 0.667 times 24 divided on 0.24 times 12 ohm times 50 kilo equals to 111 microfarads, and for V in equals to 14 volts. We follow the same procedure because the inductance is 177 microhenry and the capacitance is 105 microfarads. So we pick the maximum value for our converter, which is, if we choose the inductor, we use 177, and if we choose the capacitor, we choose the capacitor that's larger than 111. So the third question asks us to calculate the critical value of load resistance, and for the input is 12 volts. So for input is 12 volts. Our critical average current of inductor is delta IL divided on 2, and it's 1 amp divided on 2, which is 0.5 amp. So our critical resistance equals to V out squared divided on average IL times V in times D equals to 24 squared divided on 0.5 times 12 times 0.667 7, we got 144 ohm. And the fourth question asks us to calculate when the load resistance is 200 ohm, when the PWM is 50%, what is the output voltage value? So the first step is we do when Vin equals to 14 volts, and we do all these things, and we do same as question C. We calculate the R critical for 14 volts. I will not repeat those things. I will only tell you that now the converter works in DCM mode. So our Vout equals to minus dt times Vin times square root of R divided on 2LT. The Vout equals to minus 0.5 times 50k times 14 volts times square root of 200 divided on 2 times 177 times 10 to the power of minus 6 and times 50k, and we got the output voltage value is minus 23.5